Bonjour à tous. Alors, Madame Bell va arriver dans quelques instants, traverser Paris depuis l'Angleterre. C'est pas si simple que ça. C'est un vrai privilège de la recevoir ce soir. Hein. Vous savez, si vous êtes présent, c'est que vous savez qui c'est. Je suis très contente de voir autant d'étudiants, quelques diplômés aussi, pour venir la saluer. Peut-être que quelqu'un peut faire un propos introductif. Je regarde les enseignants d'astrophysique. Alors c'est l'asso IPSA qui a prévu un mot d'introduction. Bon, alors les étudiants, ça va? Les partiels? Est-ce que vous avez vu qu'il y avait une belle soirée pour les diplômés vendredi? Vous aimeriez être invité? Alors, est-ce qu'on a des étudiants qui étaient à IPSA? Alors, qu'est-ce que vous faites maintenant? Hein? Vous êtes plus à IPSA? Ah, d'accord. Bon, alors, qui est-ce qui veut présenter l'asso avant que l'asso arrive? Allez. Oh, les timides, c'est pas possible. Allez.
Donc bonjour à tous, nous on est... Alors bonjour à tous, moi je m'appelle François Nollet, je suis le vice-président d'IPSA Vega. Ici on a notre autre vice-président, Baptiste Veillot, si tu veux te présenter aussi. Je te mets dans le coin. Donc moi je suis en 3e année, je suis responsable du pôle ingénierie de l'association. Donc nous à IPSA Vega on fait plein de choses, on construit un télescope, on fait des missions scientifiques, donc on a notre responsable scientifique qui va vous expliquer un petit peu ce qu'on fait à l'asso en tant que mission scientifique. Pour ma part je suis en charge de construire un télescope, on construit un télescope de type stroke pour ceux qui connaissent. Donc c'est un télescope qui est repliable sur lui-même, sauf qu'en plus de ça on est parti sur une architecture de serrurier, donc c'est-à-dire qu'on fait en sorte que la déformation sur le miroir primaire et sur le miroir secondaire soit la même. Et donc on va présenter un petit peu les missions scientifiques qu'on fait.
Donc par rapport aux missions scientifiques, en fait, on a un programme de collaboration qui s'appelle le programme Gemini Pro-AM. C'est un programme de collaboration entre amateurs et professionnels de l'astronomie. Et pour faire simple, en fait, on a 3 grands projets qui sont dans ce programme-là. On a BSN qui s'appelle Binary System of South and North. Et c'est un projet en fait d'observation d'étoiles variables, des binaires éclipses, plus précisément. Et on va en fait observer les variations de magnitude, pour faire simple la luminosité d'une étoile, sur une période, donc sur sa période, parce que ce sont des binaires éclipses, donc c'est-à-dire que ce sont 2 étoiles qui tournent autour d'elles-mêmes, pour faire très simple. Et en fait, on va donc observer la variation de cette magnitude, cette luminosité, puis représenter sur un diagramme qui représente du coup la différence de magnitude en fonction de la période. On a aussi un autre projet qui s'appelle 10 parsec. C'est un projet en fait qui à la base qui permet de vérifier les données du catalogue du satellite Gaïa. Donc Gaïa, c'est un satellite qui a été lancé en 2013 par l'Agence spatiale européenne et qui fait des mesures astrométriques, donc qui observe tout un tas de coordonnées et d'objets célestes qui relèvent ces coordonnées. Et donc nous, on ne va pas forcément relever les coordonnées, mais on va surtout vérifier les données qui ont été prises et relevées par Gaïa, donc pareil dans tout ce qui est en rapport avec les étoiles binaires notamment, et aussi les exoplanètes. Et donc c'est dans un rayon de 10 parsecs, et un parsec c'est environ 3,33 années-lumière, donc ça fait, oui c'est ça, et donc ça fait 33,3 de rayons du système solaire, voilà. Et après le dernier projet c'est Exoclock. Exoclock c'est un projet de visualisation et de relevé de données sur les transits exoplanétaires. Donc, pour faire simple, une exoplanète, c'est une planète située en dehors du système solaire. Il y en a énormément. On en a 8175 au total, mais pas confirmés. Il y en a à peu près 3000 de confirmés pour l'instant. Et pour faire simple, ou 5000, il me semble, je ne me souviens plus exactement, il me semble qu'il y en a 3000 par Kepler, donc c'est un satellite qui a observé de 2009 à 2014 toutes les exoplanètes présentes assez proches du système solaire, et il y en a à peu près 5000 de confirmés au total. Et en fait, donc, ce programme-là, c'est un programme avec la mission Ariel, qui est une mission aussi de la NASA, si je ne dis pas de bêtises. Et en fait, on va observer donc, le passage donc, par transit de l'exoplanète devant son étoile hôte pour relever une variation aussi de luminosité, de magnitude, et ensuite traiter ces données et les transmettre sur le site d'Exoclock, et ainsi avoir des données intéressantes. Et ensuite, toutes ces données, soit on va nous les analyser, faire des publications, ou alors on peut les transmettre grâce au programme Gemini Pro AM pour ensuite permettre des professionnels de faire leurs publications et d'être cités en toute quantité IPSA Vega et IPSA plus globalement. Voilà.
Voilà, donc si vous voulez nous rejoindre, on est présent les jeudis après-midi pour faire ça. On fait également des missions un peu plus simples. On fait du traitement d'images classique, on fait des observations le soir, notamment à Butier, dans la base de loisirs, où il y a un télescope. On est habilité à manipuler en totale autonomie. Et donc, si vous voulez nous rejoindre, c'est IPSA Vega, et vous pouvez également nous suivre sur notre réseau social Instagram, @IPSA Vega. Voilà, merci de votre écoute.
Bravo. Il y aura un QCM à la fin de la conférence sur ce qu'il vient de dire. Alors, on a quelques enseignants qui font de l'astrophysique ici. Tiens, Anita, c'est quoi un astrophysicien ?
Bonjour à toutes et à tous, moi je suis Anita Lekic, je suis enseignante et chercheuse depuis très peu de temps, voilà, en visiteur longue durée grâce à mes collègues au LTE. Moi je suis cofondatrice de l'association IPSA Vega depuis 10 ans, cette année en fait nos 10 ans. Et qu'est-ce que fait un astrophysicien ? De la recherche, voilà. Son laboratoire, c'est les objets qui sont soit au niveau du système solaire, soit dans la galaxie, pourquoi pas, donc des étoiles, des galaxies. Voilà. Notre laboratoire, c'est effectivement les objets célestes. Et puis, il y a différents types d'astrophysiciens. Il y a les planétologues qui peuvent travailler sur les objets du système solaire et les petits objets, les petits corps du système solaire. Et puis, il peut y avoir aussi des cosmologistes qui travaillent sur les grandes structures de l'univers. Voilà. Et puis des astrophysiciens qui font de la spectroscopie, pourquoi pas, pour étudier la lumière des étoiles, de tout objet. Voilà, donc dans l'association, on a eu plusieurs missions. Donc c'était Baptiste qui en a parlé. On fait aussi un petit peu de spectroscopie quand on va dans la base de loisirs de Butier, donc n'hésitez pas à venir avec nous si vous le souhaitez. Voilà. J'ai pas préparé le discours, désolé. Il y a d'autres astronomes dans le coin.
Et alors, Vincent, un astrophysicien, si j'ai bien compris, c'est un rêveur, non ?
Bon, alors pour 4 heures. Madame Le Geek a quand même pas mal bien résumé. Bon, après l'astrophysique, c'est vrai, on dit qu'on est astrophysicien, mais il faut toute une vie. Il y a tellement de domaines. Vous avez la cosmologie, vous avez la spectro, comme tu disais, il y a la planétologie, vous avez ceux qui s'occupent des intérieurs et ceux qui font de la dynamique d'atmosphère, il y en a qui font des anneaux, aussi, qui essayent de... Non, mais... voilà, il y en a qui font de la formation planétaire à plein de choses. On ne peut pas tout traiter, hein. C'est pour ça que voilà, des chercheurs, vous avez vraiment, on se spécialise de bout en bout. Oui, il faut être rêveur parce qu'il faut aimer ce qu'on fait. Alors il y en a qui disent que c'est compliqué, bon, quand on aime, on voit pas la complexité. Moi personnellement, je fais de l'astrométrie, donc ceux qui sont en aéroclate, là, ils l'ont compris cette année. Il y en a d'autres qui font des petits corps. Voilà. Donc oui, il faut rêver, et puis l'avantage c'est de partir en mission, de pouvoir continuer à observer et de s'émerveiller tous les jours.
C'est bon, on peut l'applaudir quand même. Et alors, Jocelyn, Armageddon, c'est pour maintenant?
Non, il n'y a pas vraiment de risque. Après, effectivement, les petits corps, désolé. Il a failli y avoir un risque, mais non. En fait, l'événement important en fait, pour Armageddon, c'est justement dans un peu moins de 3 ans maintenant. En fait, ça sera le 13 avril 2029, où il y aura un astéroïde qui s'appelle Apophis, qui passera à proximité de la Terre. Alors on sait maintenant depuis pas mal de temps qu'il n'a aucune chance de percuter la Terre à ce moment-là. Par contre, ça sera un événement à suivre parce que en fait, en France, on sera bien placé pour observer cet astéroïde. Il sera visible à l'œil nu, il se déplacera très très vite dans le ciel, donc ça sera vraiment une occasion unique. Donc vous pouvez noter déjà dans votre agenda, 13 avril 2029, en espérant qu'il fasse beau ce jour-là. Oui, effectivement, il y a pas mal de missions qui vont être à destination de cet objet-là, à cette occasion justement de son passage proche à proximité de la Terre.
Voilà, astrophysicien, c'est pas juste un mot qui claque bien, c'est aussi super sexy comme métier en fait. Non ? Alors, on a une spécialiste, en attendant Jocelyn, toujours. On a une spécialiste, je crois, des pulsars. C'est ce qu'on m'a dit, non? Alors dites-moi ce que vous faites.
Bonjour, alors je suis tout sauf spécialiste. Je suis maîtresse d'école, donc je suis absolument pas scientifique, rien de tout ça. Donc j'essaye déjà de comprendre votre langage. Mais par contre, je suis pleine de bonne volonté pour travailler avec les jeunes élèves. Donc dans la classe de CE2, CM1 où depuis 5 ou 6 ans, je travaille sur donc justement tout ce qui est aérospatial et aéronautique. Donc les quiz pour vous, qui a travaillé sur l'aéronautique ou l'aérospatial quand il était à l'école primaire? Levez pas tous la main à la fois. Très bien. Justement, monsieur me posait la question. Donc voilà. Donc dans l'éducation nationale, j'espère quand même que je vais apporter une petite graine. Et l'idée, c'est de faire réaliser des carnets de voyage sur tout ce qui est spatial. Et donc je recrute bénévolement des experts ou des expertes pour permettre de jolis modèles et de comprendre ce que moi je ne comprends pas. Voilà, parce qu'on a beau être polyvalent, nous ne le sommes pas. Et donc dans ce cadre-là, nous avons travaillé sur qui est Jocelyn Bell Burnell, et les élèves ont écrit une carte pour Jocelyn. Et comme ils ont trouvé que c'était pas très juste qu'elle n'ait pas le prix Nobel, ils lui ont créé une médaille en 3D, en imprimante 3D. Et donc avec un album que j'ai créé pour les enfants. Voilà. Donc je suis chargée de l'apporter.
Bon, on a des étudiants de l'aéro 1 qui sont chargés de faire une mission humanitaire. Voilà, ils pourraient très bien venir, ça peut compter ça aussi, hein, de venir un peu diffuser l'esprit scientifique dans les écoles, parce que ça naît très tôt, la passion pour l'aéronautique et spatiale. Ou alors, qu'est-ce qu'on n'a pas interrogé? Alors, IPSA, est-ce que vous avez des filles dans votre asso? C'est un truc de mec, non? Alors, est-ce qu'on peut être une fille et aimer les observations de nuit?
Bah, après, c'est...
Bonjour, moi c'est Chloé, j'ai été secrétaire du IPSA pendant 2 ans. Après, c'est un discours, je pense qu'on entend beaucoup de nos jours, mais je pense que tout est possible, même en étant une fille. Là, c'est pas parce qu'on est une fille qu'on peut pas faire certaines choses que font aussi les garçons. C'est vrai que d'observer le ciel, on a 2 yeux, on peut tous le faire, quoi.
Alors, vous voulez pas donner un mot d'encouragement aux plus jeunes pour se lancer dans l'aventure d'IPSA Vega? Il faut quand même faut se lever la nuit. Voilà, les observations, vous les faites pas à 20h, je pense, hein, non?
Si vous êtes insomniaque, bienvenue chez nous. Moi, c'est vrai que j'aime bien dormir la nuit, mais après, comme quoi, tout est possible. Hein.
Voilà, avis aux insomniaques, donc. Alors on a quelques VIP, on a de la chance, ils vont pouvoir se présenter. Non, on a de la chance qu'elles soient en retard, Jocelyn, parce que comme ça on a le temps de faire le tour de l'amphi. Attention, parce que je viens vers vous.
Fallait pas me dénoncer. Bonjour, alors moi je suis Brigitte Sandin, je suis professeure au Muséum national d'histoire naturelle, je travaille sur les météorites. Voilà. Donc les cailloux qui tombent du ciel, les observer, qu'est-ce qui se passe quand ils traversent l'atmosphère, et je dénonce Jocelyn, parce qu'il nous a fait une magnifique photo quand il y en a une dont l'arrivée a été annoncée il y a 3 ans, et je l'utilise tout le temps. Tout le temps. Donc Jocelyn, il doit avoir les oreilles qui font ding, ding, ça y est, il a utilisé ma photo, ding, ding, ding. Voilà, donc c'est des cailloux qui tombent du ciel, qui nous racontent l'histoire de la genèse et de l'évolution des planètes. Donc moi, je travaille vraiment sur la formation du système solaire et sur l'évolution des planètes, en particulier de la planète Mars, avec des cailloux.
Bon, ça y est, on sait faire. Je me présente vite fait. Je m'appelle Daniel Kunt et je m'intéresse aussi au laboratoire l'univers, mais un peu plus grand, puisque je m'intéresse surtout aux galaxies, cosmologie, galaxies. J'ai commencé à travailler sur l'abondance de l'hélium primordial. Déjà, ça fait peur. C'était la quantité d'hélium qu'il y a dans l'univers, et puis ensuite sur la formation des galaxies. Non, parce que ça c'est le sujet général, mais c'est le moyen pour y arriver qui est intéressant, évidemment les grands télescopes à Hawaï ou au Chili, et surtout depuis une vingtaine d'années, j'ai surtout travaillé avec le télescope Hubble, spatial Hubble, parce qu'il permettait d'aller regarder ce qui se fait dans l'ultraviolet, et c'est important l'ultraviolet parce que toutes les galaxies, en particulier les galaxies qui sont assez proches de nous, émettent beaucoup de lumière dans l'ultraviolet, surtout celles qui forment de nouvelles étoiles, des étoiles de grosse masse. Plus les étoiles sont massives, et plus elles sont chaudes, et plus les températures sont élevées, bien plus elles émettent de l'ultraviolet. Voilà, je me suis amusé à faire ça. Et puis ce qui m'intéressait aussi, c'est que c'est justement de faire ce qu'on fait aujourd'hui, c'est de dialoguer, partager les connaissances, en partant du principe que accumuler des connaissances sans les partager, ça ne sert pas à grand chose. Voilà. Je passe la parole à mon voisin.
Bonjour, alors moi je suis Alain Le Cavalier, je travaille à l'Institut d'astrophysique de Paris et je fais partie de la catégorie de tout à l'heure qu'on disait astrophysicien. Et donc je vais rebondir sur la question qui était posée, c'est quoi un astrophysicien? C'est une question qu'on me pose souvent quand je reçois des collégiens, des lycéens, etc. C'est quoi le métier d'être astrophysicien? Et je donne comme réponse que être astrophysicien, c'est avant tout un métier de recherche, c'est-à-dire que le cœur du métier, c'est de faire de la recherche, c'est-à-dire accroître les connaissances. On connaît un certain nombre de choses dans l'univers qui nous entoure, en biologie, en sociologie, en mathématiques, en physique, et aussi en astronomie. Donc on utilise terme un peu pompeux d'astrophysique, parce qu'on utilise les lois de la physique, mais au fond c'est l'astronomie avec les lois de la physique. Et donc on me demande c'est quoi, donc moi je réponds c'est un métier de recherche. Le métier c'est d'accroître les connaissances et l'objet de la recherche c'est des astres, donc tout ce qui concerne l'univers, les planètes, etc. Et au fond, un astrophysicien c'est tout sauf un astronome amateur qui a fait de l'astronomie d'amateur son métier, qui est payé pour faire de l'astronomie d'amateur. En fait, dans un sens, je vais presque dire le contraire de ce que IPSA vient de dire, où ils ont montré que ce que je dis est en partie faux. On peut faire des observations avec des télescopes de taille relativement modeste, qui sont utiles pour ce qu'il a appelé les professionnels, donc utiles pour la recherche. Donc il y a un pont entre les observations de l'astronomie d'amateur et la recherche scientifique. Il y a un pont qui existe, mais il est quand même assez étroit de mon point de vue. C'est juste quelques niches. Typiquement, exoclock, c'est extrêmement intéressant parce que l'exoclock, c'est voir à quel moment la planète va passer devant son étoile pour en faire des observations, des télescopes spatiaux qui ont besoin de savoir à quel moment la planète passe devant. Donc c'est très utile que des astronomes amateurs, entre guillemets, enfin amateurs très très avancés, hein, quand même, il faut être réel, c'est pas juste le petit télescope de l'astronomie 2000 que vous avez eu pour boîte de Noël à l'âge de 10 ans, hein, c'est un peu autre chose. Mais il y a un pont, mais globalement le métier d'astrophysique, c'est un métier de recherche qui n'est pas un métier d'astronomie d'amateur, payé pour faire de l'astronomie d'amateur. En fait, c'est vraiment un métier de recherche. Et donc la recherche, je disais, c'est de accroître les connaissances. L'objet, pour moi, c'est les exoplanètes. Ça pourrait être de la biologie, ça pourrait être des mathématiques. Il se trouve que je suis tombé dans la marmite quand j'étais petit, et donc je fais des étoiles, des planètes. Le message que je veux vous donner, puisque vous êtes tous étudiants, c'est que quelle que soit l'activité que l'on ait, que ce soit un métier de recherche, un métier d'ingénierie, à un moment donné, on utilise tous les mêmes outils, qui sont les outils des mathématiques et de la physique globalement, en fait, de la façon les outils de l'ingénierie que vous utilisez, et qu'on peut faire toutes ces activités très bien que si on les maîtrise parfaitement. Et si vous êtes là aujourd'hui, c'est pour voir ce qu'on peut faire quand on maîtrise les outils, et ce que Jocelyn Bell va nous décrire, c'est ce qu'on peut faire quand on maîtrise les outils. Et aujourd'hui, donc, vous êtes là pour rêver de ce que vous pourrez faire plus tard, ou des choses similaires que vous pourrez faire plus tard, mais vous pourrez les faire que si vous maîtrisez les outils pour le faire. Et donc, bravo à vous d'être là pour apprendre les choses qui vous permettront d'être utiles à la société d'une manière générale.
Bonjour, c'est difficile de passer après ça, j'ai plus rien à dire. Je suis Clément Ranc, je suis maître de conférence à Sorbonne Université, je travaille à l'Institut astrophysicienne de Paris. Alors mon domaine d'activité c'est aussi la détection d'exoplanètes, alors par des méthodes un peu particulières pour vous faire rêver un petit peu. Je travaille sur les micro-lentilles gravitationnelles. Donc je cherche des planètes dans des mirages en quelque sorte. Donc voilà, on a le droit de rêver aussi de temps en temps, même si le quotidien du chercheur, c'est quand même souvent technique. C'est quand même très agréable et qu'on utilise, comme tu disais, Alain, des techniques qui sont utilisées parfois de sciences des données, même dans l'industrie, dans la pub. Là, vous savez, quand vous allez chez Carrefour puis qu'on analyse vos données pour savoir ce qu'on vous montre, il y a des techniques derrière qu'on utilise en fait nous pour faire de la science. C'est la même chose, mais c'est quand même super sympa de temps en temps de se rappeler que nous, ce qu'on cherche à détecter, c'est des planètes ou qu'on cherche à faire avancer la science à notre niveau, quoi. Alors, sur la même ligne, en fait, tu m'as inspiré. Donc moi, en fait, je fais moitié recherche, moitié enseignement, du coup, à l'université. Et je voulais prolonger ta pensée en disant que je trouve que souvent, il y a des découvertes qui sont faites par des liens qui sont faits entre des domaines différents. grâce à des techniques qui sont partagées. Et donc, en fait, effectivement, vous avez un bagage, enfin, en fait, vous êtes très polyvalent, vous avez une formation qui vous apprend plein de choses. Vous ne savez pas encore exactement, j'ai vu un petit peu le tableau là, de vos anciens étudiants qui font plein de choses différentes, en fait. Donc, c'est une preuve que vous êtes... Exactement. Même. Donc ça confirme en fait ce que tu disais, et donc vous êtes très polyvalent, et donc vous êtes apte justement, vous allez être amené, vous allez être dans cette situation où vous allez peut-être faire des liens qui vont apporter justement des nouvelles idées et qui vont débloquer des choses qui après évidemment on fait un petit pas, et c'est ensemble qu'on fait des grandes découvertes, quoi. Voilà, je sais pas, donc j'ai hâte de vous recroiser dans nos laboratoires, dans les conférences, un peu de partout, dans les stages, et puis en tant que collègue, bientôt.
Tiens, ça tombe bien, il n'y en a pas qui cherchent des stages aérocap, parce que dans les laboratoires de recherche, c'est hyper intéressant en fait, non? Déjà trouvé? Ah, voilà. Ah, il y en a un là qui a l'air très intéressé. Alors, vous voulez rechercher un stage dans quoi, vous? On va vous le trouver là en live, vous allez voir. D'abord, est-ce que vous avez tout compris de ce que Vega a raconté? Ah, bah c'est bien, il a tout compris. Alors.
Bonjour à tous, je m'appelle Robin. Alors oui, je recherche un stage, je suis en R4. Je recherche un stage, alors l'astrophysique, j'en entends très peu parler. Je suis un petit astronome amateur, donc ce que vous dites là, que ce soit Vega ou vous les astrophysiciens, ça met un peu des étoiles dans les yeux. Donc si vous voulez mon CV, je peux l'imprimer. C'est l'imprimante juste à côté. Mais oui, donc je cherche un stage, et justement je suis en train de me dire, ça peut être pas mal en vrai de faire de la spectro, je sais plus où des trucs là. Ça peut vraiment être sympa, et ça amènerait un peu mon côté, ma passion que j'ai sur le côté, sur mon temps libre, qui est l'astronomie, et avec mon stage de 3 mois. Donc c'est cet été, de juin à septembre, si quelqu'un a des oreilles, que vous déplace pour moi.
On va vous matcher, c'est sûr. De toute façon, il a un joli pull IPSA rose. On l'applaudit bien fort. Il doit aller imprimer son CV. Bravo à lui. Alors, ça y est, Jocelyn a bravé non seulement l'Eurostar, mais surtout le trafic entre la gare du Nord jusqu'à Ivry-sur-Seine. Donc, elle arrive. Et IPSA Vega avec. Eh bien, on va bien l'applaudir. Voilà. On va l'installer.
Bon, installez-vous. Can I put the mic on you?
Yes.
A microphone?
Yes. It's live?
Yes, we are live, but we chat a little bit about astronomy.
Right.
It's okay.
Yes. Hello. Wow.
J'ai bien assez parlé, maintenant je laisse la parole à Paul qui va introduire Madame Bell qui comme ça aura quelques minutes pour s'installer. Merci.
Merci beaucoup. Bon, on va du coup commencer en anglais. Comme ça au moins on va mettre le thème de la conférence déjà.
Thank you. I'm sorry I was late.
Okay.
Trouble finding
So,
the place.
last year, when Joris Bosser, who is just here, told us he could put us in contact with Dame Jocelyn Bell here, we have to admit we couldn't even believe our ears. We immediately rushed to arrange a meeting with her so we could speak with her. So, why such assignment, you could ask? To understand, you simply need to look at the incredible accomplishment of the remarkable scientist before you. For example, she was president of the Royal Astronomical Society from 2002 to 2004, was honored as Dame Commander of the Order of the British Empire in 2007, received the Herschel Medal in 1989, the Gold Medal of the Royal Astronomical Society in 2021, the Prix Jules Janssen from the Société Astronomique de France in 2022, and many, many, many more. So, Dame Jocelyn Bell Burnell is one of the most distinguished astrophysicists of all time, whose groundbreaking discovery as a graduate student fundamentally transformed our understanding of the universe. In 1967, while working on a PhD at Cambridge University, Bell Burnell discovered the first radial pulsars, rapidly rotating neutron stars that emit regular pulses of radio waves. That discovery ranks among the most significant astronomical breakthrough of the 20th century. Despite being the person who actually identified and detected this mysterious signal in the data, she was controversially excluded when the 1974 Nobel Prize in Physics was awarded to a supervisor and another colleague for her discovery.
Throughout her distinguished career, Jocelyn Bell Burnell has been a tireless advocate for women in science and has held numerous prestigious positions, including, as Paul said, President of the Royal Astronomical Society, and also President of the Institute of Physics. She has received countless honours, including being appointed then Commander of the Order of the British Empire. In 2018, she received the Special Breakthrough Prize in Fundamental Physics, worth $3 million, which she generously donated in full to establish scholarships helping underrepresented students pursue careers in physics research. A legacy extends far beyond her scientific contributions. She has inspired generations of scientists and continues to champion diversity and inclusion in the scientific community.
So now, I would like to introduce to you Dame Jocelyn Bell Burnell.
So when you're ready, whenever you're ready.
Thank you for the welcome, and thank you for your patience. My journey was slower than I expected, and I had trouble finding the place. But finally, a student found me, which was a big help. So yes, it's great to be here. And of course, one of the first things I do is look and see how many women there are in physics here. And it's better than in Britain. You have a better gender balance. Britain gradually gets better, but when I was a student, an undergraduate in Scotland, in Glasgow, our class was 49 men and me. And none of the young men, they were still really boys, would work with a woman. So I had to solve all my own problems myself. It's hard work, but you learn well. And it's gradually got better and better. And as the introduction said, I gave $3 million to fund minority in physics students. You see that with hyphens, minority hyphen in hyphen physics students. That means women mostly. But there are some other minorities in physics, to fund them to do PhDs. And our Institute of Physics runs that program, and each year they award about 6 or 8 studentships to mostly women students. And it's been going now about 4 years, and the first students are beginning to graduate with their PhDs. So, how would the organisers best like to run this?
Do you want to get to your seat or not? Do you want to get
Yes. Oh, thank you.
How are you?
That's good, thank you. Do you want to run it as question and answer?
Do you need your computer to...
If I'm going to
the
do it
presentation?
for a presentation, yes, but maybe there are lots of questions. Maybe that would be more fun. Are there lots of questions? If you think you have a question, put a hand up so as we know how many people might have questions. Oh, that's not enough for a whole session.
They're shy.
Shall I do some presentation?
But maybe it's a good idea, I think, to
Yes.
begin with the questions. So.
Right, we'll begin with the questions and see how we go.
Yes.
If you have a question at this point, please put up a hand.
Hello, I'm Julien. I would like to ask a question. If we want to, as you might know, we are engineering students,
right.
And if we want to follow with a PhD after the school, maybe you have some advice you can tell us for following this path of study.
Thank you. I know the British system and a little bit about the US system, but I do not know the French system very well. But the first thing is you must get a good degree now. You must work hard now, every year, to make sure you get a good degree. Then the next question is, what bit of physics would you like to do research in? Maybe you already know. It's helpful if you do know. I think the system here, you spend the first year of your PhD or two doing general...
Yes, epidemiology, and but we have...
Do you want microphone?
At least one alumni who from IPSA who
Yeah.
did his PhD in astrophysics.
Right.
So you can ask Mr. Robert, because he was in your shoes a few years ago, not so many years ago, and then he did his he did his doctorate.
So good evening. Thank you so much for being there tonight. I just have a first question, which is about the Fermi paradox. I pronounce it in French accent, so it's the paradox that we most heard about in civilization. What are your thoughts about it? And I also want to know about the different theories about the origin of the universe. I know it's very technical in the meaning, so, but
Yeah.
I'm very curious about it.
Yes. It's probably easiest if I follow up first about our understanding of the origin of the universe. And I think now it is very widely accepted that there was this big explosion, which we officially call the Big Bang. There will have been no sound because there was no medium to transmit the sound. It was in vacuum, emptiness, but we still call it the Big Bang. And it seems that everything and the potential for everything was in a tiny volume. And it did not like being in a tiny volume, so it went whoosh. And it's still expanding. We see galaxies still moving away from us. So you can work backwards, plot the movement backwards, and see that in the past, I think 13.6 million years ago, everything was in a very, very close proximity. We can't go back before that. So we cannot say what was there before the Big Bang, nor can we say why there was a Big Bang. But we're fairly clear that that's what there was. And because everything is expanding and getting spread out, it also means everything is also getting cooler. The temperature is going down and down and down. And so can you see what the ultimate fate of the universe will be? Big and cold and very thinly spread.
What about the Fermi paradox?
Sorry, about the
Fermi.
Fermi.
Yeah.
Fermi. Sorry, I don't know enough about the Fermi paradox to answer that question. I have to say pass.
I tried at least.
Hello, I'm not a student, I'm a journalist. With the development of so many cutting-edge instruments right now in space, underground, I wanted to know what scientific advances excite you the most, and what questions would you like the most to see answered in the coming years?
So what bits of science excite me the most, and what questions are there to be answered? Because our equipment continually gets better, we get more clever, the signal to noise gets better, we can see weaker signals, we can use shorter exposures, shorter integration times. And when we make shorter exposures, things that we thought gave us steady light or radio waves or X-rays, we suddenly find going, nothing is steady, it seems. And so there's questions about what in detail is happening, is going on inside those objects. So it's quite a big area of development now. We call it time domain astrophysics. We've got one away back there.
Questions? Who has questions? Come on, folks. It's a school or what?
So, hello, thank you for coming here. I have a question about parity in science. So, I think we are in France in physics. There's about 1/3 of physicists are women.
Mm.
What do you think needs to be done, and at what level is it?
Yeah.
Do we need to do more at the elementary level, or more at the college level? Do you think to promote parity in science?
Thank you. Yes, this country does quite well for women in astrophysics, so presumably also quite well for women in physics. There is an international astronomical body called the International Astronomical Union. Some of you may, yes, some people are nodding. And as well as your country being a member, individual astronomers can be members. And until very recently, the International Astronomical Union asked people to allocate themselves to male or female. Only two options. That has now changed. But until very recently, there were only two options. And I have been looking at this international astronomical data for 10, 15 years, maybe longer, and looking at it by country and seeing what fraction of the astronomers in each country were describing themselves as female, remembering that there were only two choices. And there are significant differences from country to country. France is one of the best for women. Britain is one of the worst. The English-speaking countries tend to be poor. European countries like France, Spain, the more Catholic countries, if I could call it that, tend to be good. Soviet Union is good, but that is because many of the men in Russia, Soviet Union, were killed, and for For a very, very long time, the women have gone out to work and the state provides care for children. So there are differences country by country, but by and large, the Latin countries are best for women in astronomy, and probably also for women in physics, and the English-speaking countries are worst. And that's true across the world. But everybody is getting better year by year. Now, the International Astronomical Union has decided that 2 categories are inadequate, and they have a new category system with about 6 or 8 options. And I can no longer do my simple analysis, which I'm a little bit sad about, but equally having just male-female is perhaps unfair.
Thank you for coming. So my question to you is, have you ever dreamed of going to space and witness things by yourself and maybe be amazed by the beauty of space? Thank you.
I think it's quite dangerous going to space, at least with our current technology. Okay, the Americans got those astronauts back, okay, but it had to be a very, very precise operation and it could have gone wrong. So I think until it's safer, I mean, if I can't even arrive in Paris on time, I should not go anywhere near space. I will mess up the arrival, the return.
Thank you so much for accepting the invitation to come here. Drawing on your own experience, do you have any advice or words of encouragement to students or young researchers that feel discouraged facing injustice in their work?
I was lucky in that I could do physics. There weren't many other things I could do. I could do geology, but the professor of geology said, no, geology is not for women. So it looked like physics was my only option. So I simply had to work hard at it and make sure I succeeded. I think it's better. Today there is more flexibility, but possibly still limits on what subjects you can combine. Timetabling constraints and things like that, which is a pity, because I think it would be interesting to do something like physics and sociology, but the timetable would never allow it.
Hello, thank you for being here. I've been a great admirer of your work for a couple of years now, and I was wondering about pulsar. How long does it take for a pulsar to die, and why can we use them as clocks? It's something that I don't really get.
Right, yes. If you measure the period of a pulsar, you can measure it to 6 decimal places, maybe 8 decimal places, and only in the very last number does it change. They are very stable clocks. Okay, the younger ones change faster, but most pulsars have that kind of accuracy. So they do make very, very good clocks, which physicists like. It's good to have clocks, good clocks. They also have very extreme physics, so they are quite a challenge to understand. They have large magnetic fields. They rotate fast, so they also have large electric fields. And the physics is hard, quite simply. They are also very compact. They have the mass of the sun in an object that has 10 kilometers radius. And I mean 10 kilometers. I do not mean 10 to the power something. You know, they are really small. The mass of the sun in a 10-kilometer radius ball. Very dense, very interesting physics. very large magnetic field, rapidly rotating, electric fields as well, almost impossible for the physicist to understand. That's fun for some people.
Did we learn much about the 3T Atlas comet?
Sorry, did?
Have we learned much from the 3T Atlas comet?
I don't know, to be honest. I don't follow comets much. I'm looking at denser and more energetic things. Although comets are very beautiful, but I have no idea whether we learned anything or lots. I just don't know, I'm afraid. Sorry.
Good evening, Madame Bell. Here at IPSA, we have philosophy classes as other international schools, I assume, and we study concepts about the universe. My question is more of belief questions, so uniting your personal thoughts and also your knowledge. Do you think that there is something past the expansion of the barrier of our universe?
Say the last little bit again, please.
Do you think that there is something past the expansion barrier of our universe?
At the expansion barrier?
Yes, I mean
the edge.
Yes,
the edge.
Thank you.
Our picture is that it is expanding into vacuum. And there's not much in vacuum. Okay, we talk a bit about vacuum energy. But I think that would be fairly small in these circumstances. So we normally consider it as pure vacuum that it is expanding into. I'm sure in part that's because it makes it possible to do some sums and some thinking. If we were expanding into something else, we would also need to know about whatever it was we were expanding into. So it's a useful assumption to make because it keeps things a little bit simpler. And we don't have a lot of evidence that actually it's different from that.
Thank you very much for being there. Just a question following yours about the pulsars. Can you give us your personal account of the discovery of the pulsars, and maybe could you tell us a little bit about your relationship with your supervisor, especially for people in the room who would like to do a PhD, for example?
Okay. So my accent is not pure English. There is some Scottish in my accent. I come from the north and west of the country, the barbarian bit of the country. The civilized bit is where Cambridge is, in the south and east. And I come to Cambridge never having been in the south of England before. And the streets are full of students, male students. Were you ever aware of our Prime Minister called Boris? Some of you, yeah. The streets were full of young Borises. Young men strutting along in groups talking about what Hegel had said and what Hegel had not said, for everybody to hear and for everybody to be really impressed by how clever these young men were. They went to schools where that was encouraged. I came from Scotland, where that behaviour is not encouraged. You do not pretend you know things that you do not know. You are more honest. And I come to Cambridge and I hear all this talk and I think, oh my God, they're all terribly clever. They're brilliant, and I'm not. they have made a mistake admitting me to Cambridge. They are going to discover their mistake and throw me out. If ever you find yourself in a situation like that, let me recommend to you what I said next. I said, they are going to throw me out, but until they throw me out, I will work my very hardest. I will do my best work, so that when they throw me out, I will not have a guilty conscience. I will know I have not wasted that opportunity. I will know I have done my best, and I just was not clever enough for this very prestigious place. And actually, if you work your hardest, you will probably win. Because I was being very thorough, working hard, I noticed on I need to stop a moment. My data comes out on very, very long rolls of graph paper. 3 centimeters, no, 4 times 3, 12 centimeters every 5 minutes. And I run 24 hours a day for 6 months. On 2 or 3 occasions, I noticed a little signal that I could not make sense of. It was not the quasars that I was meant to be studying, and it was not radio interference, because a big radio telescope is very sensitive. It will pick up pirate radio stations broadcasting on their waveband. Pirate radio stations hundreds of kilometers away. So there was this curious signal which occupied about 3 millimeters in my kilometers of chart paper. And I showed it to my supervisor. He had a rather negative attitude. He said, "You stupid girl." Sometimes I was a stupid girl, sometimes I was a stupid woman. Never worked out the difference. "You stupid girl." Oh, what have I done wrong now? He says, "It's all crammed into 4 millimeters. We can't see what the signal is. We need an enlargement." If you use chart recorders, enlargements are easy. You run the paper faster and everything gets spread out, enlarged. So after a number of false attempts, I got this enlarged version, and clearly it was pulse, 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 pulse. And my supervisor thought I had wired up the radio telescope wrong. But that's a supervisor's job, to be careful. So the next thing is to get another radio telescope, another grad student, and his thesis advisor, and tell them very quietly what we had found, and would they look with their telescope and their receiver and their chart recorder to see if they could see it. And they did. Yeah. So it's not Jocelyn. It's not Jocelyn has connected up the radio telescope wrong. It's not Jocelyn being Jocelyn. It's beyond the observatory. And so once I had found one of them, I began to notice in a few other places on my regular chart recordings, similar little signals. And I knew what I had to do before I told my supervisor. I go to the observatory and I run a rapid chart recording. And in came another from a different part of the sky, pulsing at a different rate, but similar. The first was 1 1/3 seconds. The second was 1 1/4 seconds, period. So it's similar, but it's different. So we've now got 2. And it can't be radio interference. You know, radio telescopes are very big, very sensitive. If you have a car that is badly suppressed and you drive along the road past a radio telescope, the radio telescope will pick up the of the car engine. So you have to be careful before you say, I've discovered something. You've discovered a car. So, yes, this attitude about I'm not bright enough, they are going to throw me out, is called imposter syndrome. And I think you have a similar word in French, imposter. Yeah.
Syndrome de l'imposteur.
Say it in the microphone.
In French, it's syndrome de l'imposteur.
Imposter, yeah. Thank you.
For women, mostly, you know.
Yeah. Yeah. Sorry, that was rather a long answer.
So how did you cope with the frustration?
We've got,
okay.
She's behind a pillar.
Hi, thank you for coming. My first question was kind of similar to my second. I don't know if it's a touchy subject, but 1 or 2 years ago I did a presentation about you as part of my English class, and during the research I read that, I think it's 1977, you said that you thought that students shouldn't be awarded Nobel Prizes because it would diminish their values, and I was wondering if you still believe that, and maybe why. Thank you.
Yeah, it's a very good question. And one of the complications of questions is they often have a context. And that question sometimes comes from somebody who wants me to criticize the Nobel Foundation and the people who allocate the Nobel Prize. Maybe someday you will be on a prize committee. It's a serious job. It's also a very difficult job because there will be more than one person who could very properly get the prize. And so I try not to criticize. Lots of other people have on my behalf, I must accept, yes. What was very interesting is a few years later, a colleague and good friend of mine from Princeton University called Joe Taylor, also works on pulsars, also got the Nobel Prize along with his graduate student. And he invited me to go to Stockholm for the prize ceremony. There will be people in this room who hope they get a Nobel Prize. Think twice. The week in Stockholm is exhausting. It's very special, but they work you very, very hard. It's much better to go as the guest of a prize winner. Then you don't have any responsibilities and you can really enjoy all the festivities. So I got to go to Stockholm as a guest of Joe Taylor, who along with his graduate student, former graduate student Russell Hulse, got the Nobel Prize for the discovery of the first pulsar in a binary system, which introduces a lot of interesting physics. And I would say it's much better to go as a guest than to go as the main recipient. You can have fun without the exhaustion. You had a question.
You don't seem frustrated by the fact that they swept away the Nobel Prize from you. How do you do that?
One of the things I have learnt is that if you get a Nobel Prize, you never get anything else, because people feel they cannot match the Nobel Prize. So the Nobel Prize is the end of your career. You're thereafter. If you do not get a Nobel Prize, you get every other prize there is. And every year or 2 or 3, there is a prize ceremony and a party, and it's fun. So I think that's a better route.
You are a role model for many young girls and women in science, and I was wondering, when did you realize you could act and you had to act to promote them?
It comes gradually because the discrimination is subtle, little bits here and there, many minor injuries. You know, like my geology professor saying, no, women cannot do geology. And these gradually add up. And I must have been about 40, age 40, when another woman scientist about the same age said, there are some of us getting together to think about what we can do for women in science in Britain. There were 2 of us who were physicists. One was a biologist, one was in computer science, one was in engineering. It was like that. And we were all at the level of, well, in the British system, becoming professor. And we thought and we talked and we tried. And then somebody said, you know, university vice-chancellors, that's presidents in your language, university presidents are competitive guys. They were all men at that stage. If we create a competition for the most woman-friendly university, they will compete. And she was right. We had very little money, but we bought a glass rose bowl and we announced this competition, and maybe 15 or 20 universities applied. We judged the applications, we identified the best one, we presented the Rose Bowl. We did the same thing the next year, slightly more applications, presented the Rose Bowl. After doing this for maybe 3 or 4 years, we now have had a lot of applications, and in those applications a lot of good ideas. And putting together those good ideas, we created what has become known as Athena Swan. Athena was the name of the scheme that won the first year. Sorry, this is going to be a British pun. Scientific Women's Academic Network, SWAN, Swan, won the second year. And by about year 4 or 5, we could draw up a questionnaire, things that we could ask about the number of women, excuse me, and their status and that kind of thing. And we called the programme Athena Swan, after the first 2 successful programmes. Actually, I've got some, I think. Thank you. Does that answer your question? Good.
Thank you. If I'm correct, you discovered for your phases like 180 quasars, and I was wondering what does it take for a black hole to become a quasar and acquire its electromagnetic force? Thank you.
Yeah. Well, our understanding of quasars is still growing, I have to say, but we're now, I think, broadly agreed that in the centre of a quasar there is a black hole with a mass about order of magnitude, million times the mass of the Sun, some bigger, some smaller. And this central black hole, through its gravity, controls a lot of the shape of the galaxy, the nature of the galaxy. And it's now regularly accepted that there are these massive black holes at the centres of quasars. And we know of a lot of quasars, and I don't think that's in great doubt. The other thing that I find very exciting is the opening up of a new spectrum. How many people here have heard of gravitational radiation? Put a hand up. Oh, you're good. Great. Excellent. So if a massive object is accelerated, it emits gravitational waves. You can think of it as fluctuations in the gravitational field. And these gravitational waves were first picked up, it was maybe 10 years ago now, 8 years ago, not very long ago. And I was watching the development of that field, and I knew there would be a detection someday. I was not sure I would be still alive to see it. But yay, it's happened. And so astronomy, astrophysics is getting much broader. Not only do we do the whole of the electromagnetic spectrum, radio, ultraviolet, optical, infrared, well, I've forgotten X-ray, gamma ray, you know, all that. There is now also a gravitational wave spectrum, a whole different spectrum that we are beginning to exploit. And it's a very exciting time. That, along with neutrino astrophysics, which is another very new one that is exciting. There's lots happening in astrophysics. Go do research in astrophysics. There's somebody. Okay.
So with all those exciting fields in astrophysics, how do you, when you were a graduate student, how did you choose the field you worked in? Was it a conscious choice, or was it just going with the flow, going with what opportunities you had?
Was it a conscious choice to choose radio astronomy? Is that?
Yes.
Yes. Yeah. Yes, it was a very conscious choice, but maybe for the wrong reasons. I became interested in astronomy when I was this sort of height and had not fully thought it through. It was when an astronomer said to me, "You have to be good at staying up at night. You work at night," that I thought, oh, I need my sleep. I like my bed. So I can't be an astronomer. But then I got to hear about astronomy at other wavelengths. Optical astronomy is the oldest, the original astronomy. But now there's radio astronomy, millimeter wave astronomy, infrared astronomy, ultraviolet astronomy, X-ray and gamma ray. That's the electromagnetic spectrum, right across that spectrum, as well as the gravitational wave spectrum that's just opening up, and some of the particle astrophysics like neutrinos that I've mentioned. So there's lots still opening up. It's a really exciting time. And if you wanted to pick a really exciting field, I'd say go either for neutrino astrophysics or gravitational wave astrophysics. I think those are the newest areas and will probably produce some of the biggest revolutions and surprises and excitement.
Good evening, madam. Is there another study that you worked on that you particularly appreciated, and why?
I've had a large variety of jobs. In fact, I have had a crazy career, because for a good many years I was married and we would move to another part of the country for my husband's job. And then I would see if I could get a job at the nearest astronomy place. That's why I went from radio astronomy to gamma ray astronomy, and then to X-ray astronomy, and then to infrared, and then to millimeter. You know, utterly lunatic career. But it certainly had a lot of fun, and because I've worked in all these areas, I understand better than many people the significance of new results that come in. but I've also been one of the few people watching the development of gravitational radiation, and that was through a university contact. I'm now also having to watch neutrino astrophysics because there's developments there, and I can't say I have any background in neutrinos, so I've got to learn it as well. But there's lots happening, lots and lots.
There's one question I kind of not asked it, and I was wondering, I mean, in your career today, what is the most difficult, or what is the main unanswered question in astrophysics for you?
I'm not sure I can identify that question at the moment. I think it will come either from neutrino astrophysics or from gravitational radiation astrophysics, because those are the two areas that are really breaking new ground, very different from anything else we have done. A lot of the rest, it's sort of an extension of the electromagnetic spectrum, but those are, you know, outside, different from the electromagnetic spectrum. Cosmic ray physics would also fall into that same area, but I'm not aware of great excitement coming from cosmic ray astrophysics at the moment.
I'm very afraid of the question that I'm going to ask right now. It's more about artificial intelligence. Do you think it's a tool that may help you to find new techniques in observation, in astrophysics?
What? Say the tool again?
Artificial intelligence. Yeah, do you see it as a help tool or as an enemy?
I still, sorry, haven't caught the topic.
AI.
Oh, AI. Oh, yeah, sorry. Right, yes. Okay. Yes, that's driving things quite hard at the moment. I think for me, the question that I want to ask first there is it going to enable us to help to think in a different way, or is it more of the same but going deeper? More sensitive. I think it's important we keep finding new ways. It's also important that we have more sensitive things, but also to diversify.
The conference is called You Are Made of Star Stuff. Can you explain in which way we can say that?
Right, okay. So the Big Bang at the beginning of the universe created hydrogen, the nuclei of hydrogen atoms and the nuclei of helium atoms, and not much else. Maybe tiny amounts of other things, but not much else. We know that there is a greater diversity of chemical elements in the universe. You know, we can see the spectrum of nitrogen atoms and carbon atoms and oxygen atoms. And so then the question is, where did those atoms come from? And the quick answer is they came from stars, particularly big stars, massive stars that run through many, many cycles, nucleosynthesis cycles. Hydrogen converts to helium, helium converts to carbon. Each of these steps release energy. And you can end up with some quite big atoms, nuclei of atoms, inside one of these big stars. And that big star often ends its life by exploding. And this lovely diversity of nuclei, chemical elements, gets spread throughout the universe. So in your body, there's carbon, there's oxygen in your lungs, there's calcium in your bones, there's iron in your bloodstream. There's a number of trace elements that are very important for mental health. there's actually quite a range of different atoms in your body. And apart from the hydrogen and the helium, all those elements were created inside stars by the nucleosynthesis that made the star shine. Or put differently, the star shine is creating the nuclei of oxygen atoms, carbon atoms, calcium atoms, iron atoms. Some of the bigger ones are actually produced when a big star explodes at the end of its life. But all the heavy atoms, anything heavier than helium, came from the stars. There's no other place those atoms, those nuclei were made. So many of the atoms in your body have nuclei that were created inside stars and dispersed by a big explosion, wrecking the star at the end of its life, and ultimately getting gathered up into Earth and its atmosphere, and ultimately into your body through the food you eat. So most of the atoms in your body were created inside stars. You are made of star stuff. You have to shine.
I'm very curious about the gravitational lens, and I wonder if there are any link with the pulsar or quasar.
I missed the first sentence. You're very curious about
Gravitational length.
Radiational?
Gravitational lens.
Gravitational.
Gravitational lens.
Gravitational lens. Right, there's gravitational radiation, which is really important. Gravitational lenses can happen usually temporarily because the galaxy is actually in motion and it does not rotate like a solid body. There is differential rotation. And so sometimes you're seeing things, so to speak, one way and sometimes another way. But the galaxy, the stars, the universe are very much part of us because the atoms in our bodies came from the stars. And you can't get away from that.
I have a second question. It is about the black holes. So you told that in the pulsars you have black holes. And can you explain us, please, what is the principle of the singularity that resides in the black holes?
Right. Black holes and pulsars are actually different things. There are not black holes inside pulsars. But pulsars are probably the most dense thing that did not become a black hole. So they're the last stop before black holes as you collapse something down. The insides of neutron stars are extremely interesting because they are very, very dense. And the physics is quite hard to understand because it's so very dense. But we are now quite clear that there are also black holes. We quite often find a binary system, two stars, where actually one of the stars is a black hole. So it's a black hole orbiting an ordinary star. It's wrecking the ordinary star in the process because its gravity is so strong, it's gradually pulling material off the ordinary star onto itself. And as that material gets pulled in and down, it gets hotter and it can radiate. And many of the X-ray sources that we know of in our galaxy are an ordinary star twinned with a black hole, and the X-rays are coming from the material that is falling onto the black hole but has not yet quite gone into the black hole, so we can still see the radiation.
Hello, thank you for being here. My question was, I understood that from your parcours, the first years of your study were really stressful.
And I had a question. What would be your fondest memory as a researcher that you would like to tell us, and what helped you?
Right. My undergraduate course was very tough to begin with. I went to university in Scotland, in the city of Glasgow. And in Scotland, the schools have a different system from the English schools. In Scotland, they do many more subjects and keep them going for longer. It's more like baccalaureate. Whereas the English school, you do probably only 3 subjects by the time you are at the top of school. And so I went from the English system into a Scottish university, and there was definitely a mismatch. I was way ahead in physics and way behind in chemistry. And it was difficult because the timetable was very full with classes and laboratories, and I had to work out a way, or I and the university had to work out a way that I could use some of the physics time, which I did not need, to study chemistry, where I did need more time. But if a student is sensible and there is some sort of mismatch like that, the university will usually help, will make some arrangement. And what they did in that case was, in the physics practical classes, we were doing again the things I had done at school, because I'd done extra physics at school. Whereas in chemistry, I was way, way behind. And so we ended up with me in the physics laboratory working on my own. In Britain, it's normal that the students work in pairs, is what happens here. Is that something similar? Undergraduate laboratories? Yeah. So I ended up, I was allowed to do the experiment again, but do it quickly to show that I could do it, and then spend the rest of the laboratory time learning physical chemistry. I know, if you're sensible and trying, the university will try to help.
So I had a question about amateur astronomy. So I wanted to know if there are some research projects in which amateur astronomers could maybe help in the research of pulsars or quasars in astronomy, or if you know, maybe.
Yes, I'm struggling to remember the name. It happened that in Oxford, where I am now based, somebody had so many photographs of, I think it was galaxies, probably, so many photographs they could never analyze them all. So they had the idea, we will put the photographs up on the web, the World Wide Web. We will put up a little tutorial teaching people what to look for in these photographs, and we will invite the public to help. And the public has loved it. The public does help, and this is happening more and more, that you can find on the web large databases that people want help analysing. And if you have any spare time, which I'm sure some of you do not, but when you have some spare time, you can go on the web and register and help analyse this data. And it's been really, really successful. For example, there was one project looking at galaxies, classifying them as spirals or ellipticals or whatever. And lots of people did this. And it was actually somebody in the Netherlands who wrote in and said, I'm enjoying doing these galaxy classifications, but what are these green peas in the corners of some photographs? You have the vegetable pea? Yeah, and they're green. They were seeing little green dots somewhere else in the photograph of the galaxy that they were meant to be classifying. And so we started this so-called green pea project. And it turned out to be, I think, oxygen-rich objects. which we had never noticed because we'd never had the time to stop and really look at these photographs. But the amateur astronomers, the members of the public that were helping, were doing a fantastic job, and that's how these green peas came to light. Unfortunately, I can't remember the name of the project right now, but I think if you went onto Oxford University's astrophysics website, you might well find the project if you wanted to help with the research, if you have not enough work to do given you by the university. Ha ha.
I had a question. You talked about the electromagnetic field of a pulsar, and how do we actually get to the formation of a pulsar, and could the electromagnetic field affect us in any way if it were like too close to us, for example?
Yes, the magnetic fields are large. You would not want to go too close because it would disrupt the electromagnetic processes in your body, which are actually quite weak, but there are electromagnetic processes in your body. So the magnetic fields are typically something, I'm going to give it to you in Gauss, I'm sorry about the old units, 10 to the power 12 Gauss, million Gauss, which is very big. And you have it rotating rapidly as well. So the physics is hard, but interesting.
I have a question. My question may seem off topic, but I was wondering from your perspective, do you think a young woman should focus on their career, or maybe it is possible to find a balance between marriage and career?
Yeah.
Thank you.
Well, you know, men seem to manage having a career and a wife. So with a little bit of equality, you'd think women could manage a career and a home, a marriage. The one difference being babies. Men cannot have babies. And childbearing is okay, it's 9 months, it's not fantastically long, but it's still very much the tradition in my country, and I don't know whether it is here or not, that it is the woman that takes care of the children. It's the woman who has to feed the baby if they're breastfeeding, and it kind of carries on like that. The woman seems to have prime responsibility. And society at large assumes it's the woman that has the prime responsibility. So if your child is sick at school, they will phone the mother, not the father. And it goes on a bit like that. So it's not a totally equal world. I mean, once you are no longer breastfeeding a baby, fathers can play the same role as women play, mothers play. But it doesn't always happen somehow. At least not in Britain.
Well, in 2026 you can have it all, you know, women and men as well. I would like, please, to say thanks to Jocelyn Bell, who came to... that it's a wonderful present that IPSA gave us for the 10th anniversary, and that's great, and you can thank them because it's thanks to them. Thanks to our friend. You know, we have a very good friend at IPSA, it's Boris Jossa. You have to follow him on Instagram. special guest in front of you, which is a school teacher actually, and she has some gifts for you from the students. But maybe we're going to let the students go because tomorrow I'm sure there's some exams.
Oh dear.
Thank you all. She's a school teacher and she's done wonderful things with the kids. She's going to explain to you, and she wrote a book as well.
I'm just here to. She's my friend, and I will translate for her. She doesn't speak English.
Thank you very much.